Prediction from line of best fit. First and foremost, I want to let you know that Mr. Delta Math's way, he shows it with a picture. Instead, we're going to use algebra for our assignment. So thank you for taking time to watch the video carefully. A researcher studied the relationship between the number of times a certain species of cricket will chirp in 1 minute and the temperature outside. Her data is expressed in a scatter plot and line of best fit below. Based on the line of best fit, what temperature would it most likely be outside if the same species of cricket were measured to chirp 96 times in 1 minute? So first things first, let's go ahead and look at the graph. Again, the yellow dots are the actual measurements. The line that's drawn here, this is the line of best fit. And we use the line of best fit to make a prediction. So first, let's go back to algebra from our first semester. And please remember that slope-intercept form is y equals mx plus b, where the letter m stands for our slope. That's how we move on a graph. And our letter b is our y-intercept, and that's where we begin. Another formula that we'll be using is finding out the formula for slope, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what we're actually going to be doing is we'll be using real world or hypothetical real world data with our algebra to prove. So the first thing I want to point out is that it tells us that there's 96 times in 1 minute. So 96, please notice that the 96 chirps would be way over here to the right. So it's actually off the graph. And this is why we're going to use algebra to prove it. And I do also want to point out that 96 chirps would be an x value. So in other words, we're going to put x into the equation we get to be able to determine what comes out. Now, intuitively speaking, you could kind of extend it over here and say, well, if it was 96, that would go up 1. And again, you could reason with it, but I want you to verify it with the algebra. So step number 1, we're going to use these two ordered pairs that they give us, and we're going to figure out the slope. So I'm going to put m is equal to, I got my subtract signs, and then I'm just going to go ahead and plug in the ordered pairs. So let's see. Y sub 2, I've got 63. And then the corresponding x value is 93. So I've got 63 over 93. The next y value will be 62 over 90. 63 minus 62 is 1. 93 minus 90 is 3. So it looks like the slope breaks down to a nice even 1/3. Got it. So now what we're going to do is we're going to take that 1/3 and we're going to substitute that in for m. Now the problem here though is we don't know what our b value. It'd be nice if this line of best fit extended and showed us exactly where it's at. But because we don't know exactly where it's at, we're going to have to take one of these 2 points and we'll substitute a y value and x value and then solve for b. Let's see, let's use 90 and 62. So my y value is 62, so I'm going to put 62 is equal to 1/3. Then my x value will be 90 plus b. I distribute or multiply 1/3 times 90, or simply 1 times 90 is 90, and then 90 divided by 3 would give us 30. Let's bring down that 62. And then to isolate b, I'll subtract 30 on each side. And 62 minus 30 is 32 is equal to b. So now I have my m and now I have my b, and we can go ahead and create our equation. So our equation is y equals 1/3 x plus 32. Now remember, over here it said that cricket chirped 96 times. So 96 chirps, again, that's along the x-axis. So right here for x, we're going to substitute 96. Let's go ahead and plug it in. Y is equal to 1/3. Again, 96 chirps plus 32. And I would have 1 times 96 is 96, and then 96 divided by 3, that would give me 32. So I have 32 plus 32, which means that y is equal to 64 degrees. So my final answer is going to be 64 degrees Fahrenheit. And hopefully we get that right. Feel pretty good about that. So I'm going to box my final answer. We'll come over here to Delta Math. We'll plug it in. Green check mark is good. Red X isn't bad, but it's an opportunity for us to look things over and make sure we can find out our mistakes. So let's put in 64 degrees. And let's plug it in here. Yep, we're good to go. And notice that Mr. Delta Math, he actually did what I told you. See how he extends it? He used the slope of 1 over 3. He went up 1, right 3. And again, there's nothing wrong with that, but I do want you to be using algebra to prove it. So you'll get two types of problems. The first type is once you come up with your equation, they'll give you an x value to put in. The other type is they'll give you a y value to put in. All right, so here's a second example. I thought I'd give you one. A researcher studied the relationship between the number of times a certain species of cricket will chirp in 1 minute and the temperature outside. Her data is expressed in the scatter plot and line of best fit below. Based on the line of best fit, how many times would the cricket most likely chirp if the temperature outside was 51 degrees Fahrenheit? So this is opposite. The last problem, they told us exactly how many times it chirped. We had to figure out the temperature. Now in this case, they're going to give us the temperature and say, well, how many times did they chirp? So as always, we got our formula for slope and our equation y equals mx plus b. We're going to start out with slope. And I'm going to choose these two first points. You can choose any 2 points that are actually on the line of best fit. So let me use red for this. I'm going to put m is equal to, put my subtract signs in here. Let me see, I'm going to do 46 over 64. So 46 over 64. And then I'm going to use 45 over 60. 46 minus 45 is 1, and 64 minus 60 is 4. So our slope is a convenient 1/4. So I have y is equal to 1/4 x plus b. And now I'm going to have to take one of these points over here, and I'm going to plug them in for y and x so we can find out what our b value is. So let's see, I'm going to use 60 and 45. So 45 is my y value. So I've got 45 is equal to 1/4. My x value that goes with that 45 is 60 plus b. So I have 45 is equal to 1 times 60 is 60. 60 divided by 4 simplifies to 15 plus b. Then I'll subtract 15 on each side. And let's see, I have 30 is equal to b. So now I have my b value and I have my m value. We can come up with our master equation to be able to solve for x or for y. So I've got y is equal to 1/4 x plus 30. But now notice over here, they said 51 degrees Fahrenheit. Remember, the temperature is measured along the y-axis. So that 51, I'm going to have to plug in for y here. So I should have 51 is equal to 1/4 x plus 30. My first step in solving for x is I'll subtract 30 on each side. So I would have, let's see, 21 is equal to 1/4 x. The quickest way to get rid of a fractional coefficient is to multiply by its reciprocal. So I'm going to go ahead and multiply by 4 over 1, or just 4, whichever you want. And actually, let's do it this way. Let's do 4 over 1 here like this. Okay, cool. So 1/4 times 4 over 1 is 4 over 4. 4 over 4 times x is just x by itself again. When you multiply by the reciprocal, it's going to change. They'll cancel each other out. Now on this side, it's really 4 times 21, which is 84, and then divide by 1 obviously is 84. So x is 84. X stands for the number of chirps. So that means that when it's 51 degrees Fahrenheit out, the cricket chirped 84 times. So I'm going to put 84 chirps. Well, technically chirps per minute. Let's box our final answer, and then we'll plug it in here, and we'll have an opportunity to get some reinforcement, whether it's good or corrective. Again, green X means we got it right. Red X, sorry, Green check mark is good. Red X is an opportunity to stop and find out our mistake. So 84. Yeah, and I bet you if we scroll down, yeah, see, he just extends his graph. His last point was 80-50. It looks like he extends his slope by going up 1, right 4, just using the slope. Again, I want you to use algebra, though. Often in real-world samples, you don't get clean numbers like this. Thanks for the time to make sure you got it right. And if you got it wrong, review to get it correct in the future.